recording the session. Yeah, I'm recording the session. And first of all, I just want to briefly introduce myself, given that I'm the one who is taking you through the first unit. My name is Xavier Aluku, and I'm a senior data scientist at Finbel Capital Limited. That's what I'm doing full time. It is a digital lending platform that deals with unsecured loans. And my main role there is to assist in data science, to assist the business intelligence team in terms of making business decisions, in terms of lending to the customers, among other decisions. So I know we have quite a number of students here, and I don't think if maybe giving each one an opportunity to do the introduction might take quite some time, but I just want us to set the rules. So I don't know if is there any background noise you are hearing from my end. Am I audible? Can someone confirm?
Yes, you are.
Yes.
Okay, thank you so much. So I want us to set the rules. The first rule is that in case you are not speaking, it is advisable to mute. And if you want to speak, you can raise your hand. You can as well write a text or a chat. I'll be able to see and give you an opportunity to uh, okay, and give you an opportunity to ask the question. Another thing is that I hope you all got copy of the curriculum. I was able to share in the group both for those doing the certified data scientist and those doing the that's business analytics. As you are aware that business analytics is a subset of certified data scientists. Like a subset means is that some of the units covered, not some, all of the units. Okay, all of the units covered in certified business analytics are forms part of the certified data scientist unit. That's why most of the classes, all of the classes will be combined. Then there is where it will reach, whereby the certified business analytics students will branch off. And I hope that you are able to see that in the curriculum. Another thing is that, um, for instance, the certified data scientist course, that is, it has about 16 courses or units. I can call them units. So also you'll be meeting various trainers. I'll be taking you through the foundation course and the R essentials. You'll meet a different trainer for the statistics, for business analytics and data science. You will meet a different trainer when it comes to data visualization with Tableau, a different trainer on that is SQL. So you'll meet about, before you graduate, you'll meet about 4 to 5 trainers, different trainers along the way. So it is also very important to highlight that. Um, Another thing maybe that is very crucial maybe to highlight, I understand that we have a mixture here, both those who are working and I think university students and so on. And based on my experience, sometimes you find out that you might delay or you might be unable to join the session because of some of unavoidable circumstances. In such cases, we encourage you to, you can just inbox me, inform me that I won't be able to join the session today, so that you are able to keep our records, because you are required by, given that this course is, they are accredited by International Association for Business and Analytics Certification. And the standard is that you are at least required to attend the 80%. Another thing is that given that I don't know how many people were there during the open day, um, for those doing the certified data scientist, at the end of the course, of course, along the way you will be doing various projects and so on. But when now you will be doing the final exam from IBEC, you will have two exams for, that's the Data Science Foundation, which is a multiple choice exam, pass mark 60. Then you will have the Certified Data Scientist exam, which is a project-based exam, and you will do within a period of 2 weeks. You will be given 2 weeks to complete the project. That is an open book whereby we are allowed as AFRI CDSA mentors to guide you through the project. But by that time, based on my experience, most students are always able to do an end-to-end project, that is from gathering the data, manipulating, building those, of doing the required analysis, and even deployment for production and documentation. But for those doing the certified business analytics, your exam is one. You'll do just one exam, still from IBEC. So the certificates you will receive two, one from IBEC and one from AFRI CDSA, that shows that you went through the institute. But all in terms of supervision of the exams and everything is normally done by AFRI CDSA team. So having said that, because it is very important to highlight, in terms of the duration of the course, I hope the certified data scientist will take 7 months, including the exams, and the business analytics is 6 months. And our classes run from Monday to Thursday. On Friday, we don't have classes. The main reason, one, we do have the 7-day Adventist students, our Muslim brothers and sisters, among others. But what happens on Friday internally, we have what we call community learning. Community learning, what normal happens is that we have our former alumni, students who have covered most of the content, advanced level, and so on. And even the beginners like yourself, maybe we shall be sharing the link for you to join the community learning forum. What happens there, like currently we are doing a project on using artificial intelligence to improve healthcare in Kenya. It is an open source project. What normal happens is that those who are interested in doing those projects to continue learning and improving their skills, we segment them. Like for yourself, maybe after the first 2 units, you'll be able to do maybe data collection from the internet and wherever. Maybe you pick that I'm going to be part of the data collection team. Another team goes that I'll be able to be part of the that is data preparation. Other team will do the modeling. Others will do the deployment and documentation and so on. So that is what happens on Friday, but it is not a must. In case you can't find time, the sessions are also recorded. You can follow via YouTube. So having said that, I understand that we are from various countries here. Um, we have students from, I think we have Malawi, Rwanda, and Uganda in this session. So I also share the class a repeating link, the email invite via my calendar. In case you accept it, um, it is very important because you'll be getting reminders that you have a session at this time and so on. It is a repeating kind of a link that it is not a must that I share the class link daily on the group. Once you accept it, you just check your calendar. When it is time for the class or session, you just click and you'll be able to join. So I think I have highlighted key or pertinent issues. And before we start officially what we are supposed to cover today, I want also to give you an opportunity to ask questions. But before that, I think there's something that has come up. It is only the first unit, the foundation unit, that is theoretical, because you need that general knowledge. The rest of the units are practical, so you'll need to have at least your laptop. So from the second unit up to the last, like for those doing the certified data scientist and also business certified data scientist, I think it goes up to 16 units of courses, and business analytics, I think 11 or 12 there. All those are practicals, so you need to have a laptop or a desktop, and I think a 4 GB RAM will work better for you because of the processing speed and so on. So, Almas, I see you have the tool that takes notes, but I hope it does not violate on that it just takes the notes, but it does not take people's like the screenshots and so on, because data privacy issues nowadays, in fact, it is part of this data foundation unit. I hope it's just taking the notes, but not people's names and so on, because
Yeah,
we have to get their consent.
it's just notes.
Okay, thank you. Yeah, having said that, I want to give you an opportunity to ask questions or seek any clarifications before we start. Any questions? My classes are always interactive, very interactive, like the discussions and so on. So don't fear to ask any question. We are all here to learn, and also since I started training, I also do learn a new thing every day. Like we are learning is just like a continuous process. Any question with regards to what I have said, or what do you need to hear in terms of the operational matters that are not clear because we haven't started uh, look at the content. Yes, I can see. Yes, Ferran Jr.
Yes, I think I want to raise a question
Yes.
about the business analytics and the certified data.
Yes.
So you said we'll take the lessons together, but there is a time that we will deviate at different paths.
Not different paths, if I
Yeah,
can say, like your units are 11,
yeah.
and those that are doing data science are 16.
Okay,
Because so a data scientist is has the general, like both business analytics, data analysis, and so on content. But a business analyst has, okay, we are going to see here what business analyst does, but basically what it means, you are looking at historical data in your organization and you are trying to uh, foresee the future, like you're using historical data not to foresee the future but to analyze what happened. That is what it entails. But you will learn most of all of the units you will learn together, but you will finish earlier. I think that is the right English term to use.
okay. The only reason why I have raised that is because if a person, for example, wants to do the analytics exam
Mm-hmm,
and also wants to do the certified, because I'm taking the certified data science, but
mm-hmm.
can I do the analytics exam?
Yes, yes. If you want, you will do.
So I will get different certificates for both.
Yes, yes, yes. You'll get different.
Okay, I think that's clear.
Okay. Any other question? Yes. Exams. The multiple choice exam is okay. Maybe before I go there, at one point we might meet to present your internal projects in unit number 16. But in case you are not within, maybe you have a very busy schedule, you can still present virtually. In terms of exams, exams are computer based. You can do at our center or wherever you are. That is the the multiple choice exam. When it comes to the project exam, also what happens? They send to you a business problem with data and what is required. Then you are able to solve it. But with that, also we are allowed to guide you wherever you are. So we can always arrange sessions in case you like we are unable to maybe to or you are unable to present physically. Exam you can do anywhere. So I don't know if that is clear. I don't know who asked was it. Okay, yes. Any other question I want to start? You will have various mentors. Maybe as you have put it as lecturers, and I'll be taking on we only through 2 units. Then there is another person who will take you on statistics for data science and business analytics. Is a different person. Uh, there is a lady who will take you through uh, Python units up to data visualization with Python. Then there's another person who will take you through the machine learning, deep learning, and big data part. Then also Tableau and SQL is a bit. So you will meet about 5 people, if I'm not wrong. But in case you have any question, like on the units that I'm going to take you through, you can always reach out to me. I'll be able to assist you in terms of making clarifications and so on. So you'll meet uh, different guys and working in different industries. Like myself, I'm working in a fintech. Um, the guy taking through the statistics is working as a, I don't know, a HR analyst or something like that. But the guy taking machine learning is working as a data engineer and machine learning and data engineer in a certain UK company and so on. So they are different. We'll meet different people with different experience. Any other question before we can start? Okay, thank you. So as you are starting, as I said that do not fear. This is going to be an interactive kind of approach to learning. And this is the only unit we are going to do the theory. But the rest are practicals, of course, complemented with theory. Yes, Ferran?
I wanted, since we are doing all this data, maybe having end to end. So we will have an end to end data, for example, as you said before. For example, you take a raw data, you manipulate, maybe you make it better, then you come up with something. I wanted to ask the reason, one of the main reason I'm taking this course is, for example, if we build an application, for example, through learning this course, can we create an automated, for example, if you are in finance, you want to create an automated application, maybe you use a data Tableau or whatever it is, or Python or SQL, even Excel. Can we can you create an automated application where it you through some code or through something else you mold and make it better so that you don't do what do you call repetitive work, because that's one of the main reasons that we are taking this course.
Yeah, thank you so much, Ferran. So, yes, basically, you have mentioned like, let me just give an example. Like you have mentioned, when you mentioned like Tableau, Power BI, maybe even Excel, nowadays we have what you call BigQuery and so on that are used for data visualization. If you want to automate your work, like your dashboard, to be refreshing maybe after every 1 hour or 30 seconds, sorry, minutes, and so on, you can connect to the database directly. That's like the SQL. You will be taught you can integrate so that whenever data is being uploaded in the SQL server, it is able to be visualized in real time and your dashboards are updating. The second one, now let me give you my example like the Berry mobile app. When you go today to apply for a loan, you are required to upload your M-Pesa statement. When you upload your M-Pesa statement, we have a machine learning model that is able to extract the data. Of course, you have already trained, we know what the model will take. It will extract that data and score and decide if you are going to be given a loan and so on. So, and when you look at the curriculum, the last unit that talks about API and so on, is now when you build this model, you are able to integrate with the applications that are existing within your organization. So we have two aspects that I have mentioned. One, integrating a database with the existing tools like Excels, and so on that are used for data visualization, or building your own model. Mostly this now goes to machine learning. Then integrating with the application. Maybe you want to build what you call recommender systems. Let me say in insurance industry or wherever. Like when you are searching about a certain product, you are able to see a variety of them falling within the same line, so you can do the integrations and so on. So Ferran, I hope I have tried to answer your question.
Yes, yes, yes.
Okay, thank you. So I think we can now start. And first of all, we are going to define what's data science. And I think this is something that you have heard or have been hearing and so on. So when we are talking about data science, um, this I can say it is a very wide concept. But when we look that, we are seeing that it is a term that escapes any single complete definition, and therefore it makes it very difficult to use, especially if you want to use it correctly. Let me see if there is another question. Yes, there was someone who was asking if I'll be sending the presentations. Yes, I'll be sending the presentations and the recording. Yeah, I hope that is clear. We can proceed. So, uh, what is happening about the definition of data science? And I hope most of you also, as you are trying to enroll in this course, you have been doing your own kind of background research and so on. So, Almas, I'm just requesting you guys to be patient. We are coming there. Just be patient. Everything is well structured. So yeah, thank you. So just be patient. We will be coming there. So so mostly when you are talking about this definition, you find out that people are using it uh, uh, like they are using this definition freely with the assumption that it is universal understood. I just want to give you an example. Like when we are talking about mostly in biology, for instance, when there's anything that has been discovered or um, uh, maybe a parasite or whatever that is causing a certain disease, they give a scientific name that is universally accepted. But now, um, when you are talking about data science, we are talking about the methods, goals, and applications that evolve with time and technology. So, like for instance, here, data science in 25 years ago, it referred to gathering and cleaning data sets and then applying statistical method to that data. That 25 years ago. That's why I have said that when we are defining it, we are talking about the methods, goals, and applications, and this evolved with time and technology. So we see that 25 years ago, data science referred as gathering and cleaning data, then applying statistical method to data. And before even I go further here, do we have any person here who did maybe at undergraduate level BSc statistics? BSc statistics? Yes, Venetia. You did statistics. So what happened in the past is that we had people who were called and also Salom. We had what you call statisticians, something like that. So we have quite a number, Fiona, and so on. You see, nowadays, business analysts, data scientists, and machine learning engineers are doing the work of the statisticians. And one thing that is happening is that, especially when you look at our learning institutions, especially our universities and so on, it takes a lot of time for them to keep on updating the curriculum because the processes are long and so on. That's why, and also when you find out that, um, for instance, my case when I was still in campus, you find out that someone who started teaching very long time, like in 1990s, they are just using the same handout and so on. So you find out that those people, the statistics you are talking about is basically what you are applying in data science, in business analytics, in data engineering, and so on. So it has evolved with time. So therefore, we are seeing that in 25 years ago, it referred to gathering and cleaning data set, and when applying statistical methods to that data. Now, from 2018, this has grown to a field that encompasses data analysis, predictive analytics. Predictive analytics, what it means is that you are trying to use your data to foresee what might happen or what will happen in future. So we have seen that from 2018, data science has grown to a field that encompasses data analysis, predictive analytics, data mining. Data mining is like gathering some kind of data, business intelligence, like you are trying maybe to see, like for instance, we do have like what we call market basket analysis. Like you are trying to understand your customers. For instance, if today maybe Ferran goes to um, um, any supermarket to purchase maybe this item, there is high chance that they are going to also purchase almost a similar product or another item. So you are trying to maybe understand the behavior. Let me not use Ferran, but let us say male. When maybe a male person goes to the supermarket to purchase a certain kind of product, they are most likely also to purchase another different kind and so on. So when you are able to see that kind of behavior, you are able to make a business decision to know how you are going to put to be able to make available certain products and so on. So you see that data science now involves data analysis, predictive analytics, data mining, business intelligence, machine learning, deep learning, and so much more. We are going to define all of them. So, but um, another question is what has led to all of this? It is because like, it is said that 95% of the data that's available currently was produced in the last in the last 2 years. So nowadays, everyone has a smartphone. We are posting a lot of images in social media, a lot of content in social media, but we don't have that knowledge that this data that you are posting is really used by people to make business decisions. Like, for instance, let me give you an example. If today Uh, for instance, if every CDS is going to boost a post on Facebook with regards to their trainings, they are going to try and pick that we want this post to reach people who are interested, or people who have done statistics, or who have interest in statistics, maybe business analytics, health, and so on. So what happens is that this one, using the machine learning models, it is able to customize, to optimize the marketing strategy to fit the intended market and so on. So whenever, for instance, you go to social media and provide your details, remember that the data will be used for other purposes. That's something that you should uh, be aware of. So we have seen that the definition is a broader one as compared maybe to what we were thinking about. So now, you want to look at data. You want to look now at data. So when we are talking about data science, uh, it won't be a complete term without data. So when we are talking data science, it won't be complete without data. Therefore, when you are talking data, is the material on which all the analyses are based. And therefore, yes, Collins. Collins, I see your hand is up. You can ask your question. Collins, you can unmute and ask the question that you have.
Okay, I've said is I just have done it by a mistake. I'm sorry about that.
Oh, okay. Thank you. So, we were now looking at data, what data is, and we have said that data is a foundation of data science, and it is the material on which all the analyses are based. And therefore, we are saying that in this context of data science, there are two types of data. One, we have what you call the traditional data and what you call big data. Um, Before I proceed further, who has any insights about big data? When we are talking about big data, what comes to your mind? Anyone who can raise his or her hand so that you can try? Who has ever heard about big data and what do you know about it? Okay, no worries. We will come there. But now, let us first of all define traditional data. When we are talking about traditional data, we are talking about data that is structured and stored in databases. And this data can be managed from one computer. It is in table format and contains numeric or text values. And that's why I asked about those people who did statistics and so on. Yes, I did. I have also mathematical. I did quite a lot of statistics units back in campus. So you see, the main reason I'm saying that the current people who are doing statistic related items and so on, um, the data scientists, the business analysts, business analytics experts, the machine learning engineer have replaced it is because of they approach data with the traditional data concept. And you have said that this traditional data is data that is structured and stored in databases. What do we mean by structured? For instance, when you are being admitted at AFRI-CDSA, I'm sure the operation personnel asks you about maybe your name, your identity document, what else? Your identity maybe number, uh, maybe phone number and email. So here I'm having about 19 students. So I have name. The first one is Ferran, ID number, phone number, and so on. Another one is Fiona, Collins, and so on. So I have a list. That data is structured and is stored somewhere in a database. Then maybe what's a database? This is just a platform for storing data. I know when you learn SQL, you learn more about it. But wherever you are storing data is called a database. And this can be managed from one computer. Mostly it is in a table format. Like if you have an Excel workbook with all these details, we call it a table format. When we will be learning when we will be learning R and also Python, we will be talking about what we call data frames and so on. And this data contains either numeric or text values. Like when you are talking about numeric data, for instance, when we are storing your phone number, that's numeric. Text values, we are talking about maybe your name and so on. So that is traditional data. But now things have changed. 95% of the data that is generated is unstructured data. And organizations have been caught unaware, especially those in Africa, because when you look at most European countries and so on, this is something that they have really uh, tried to master it. So we have a lot of data. Currently, social media, in fact, social media is generating millions and millions of data. We are posting images, we are posting voice notes, we are posting text data, and so on. So when you are talking about big data, we are talking about extremely large data, and this data is distributed across a network of computers, but it is not just characterized by the volume. Of course, we have other aspects of this. So when you are talking about big data, it can be in various formats. It can be structured still. It can be semi-structured or unstructured. Like when you post your image on social media or a text, is it structured or not? It is not structured kind of data. So that is some of the big data. And organizations are using it. How are we going to use this data? When you are posting on social media, are we going to capitalize in terms of maybe customizing our marketing strategy as an organization and so on? So that's why now these emerging careers have come. That's a data scientist, machine learning engineer, business analyst, um, uh, machine learning engineers, and so on. How are we going to track and able to make sense out of all this data? So other characteristics of this big data, we are talking about variety. As I have mentioned, like this data can be in form of numbers, text, images, audio, and so on. Another one is velocity. It is retrieved and computed in real time. Like currently, if you are posting anything on social media, how much time will it take for people to get or to view what you have posted is a matter of seconds. So this data is being transmitted at a very high velocity. Another one is volume. Big data is measured, that is in millions of terabytes. This is just, it means it is a very, like the data is voluminous because um, I don't know the current statistics on how many maybe users does Facebook have in Kenya and so on, but I'm sure it's more than 20 million or even 30 million. And people are posting in just one country. What about global? We have millions of customers and so on. So the kind of data that is being posted within seconds is um, voluminous. So when you are talking about now these emerging careers, they are mostly they are mostly emerged as a result of big data. And what has led to big data is the recent development, what we call the fourth industrial revolution, and especially in these areas of mobile technology. So um, before even we go define on what do you do with data and so on. I know we shall come on to define business analytics and so on later on. But before we go there, uh, as I see that my classes are, I like it. I like them being very interactive. Maybe Samuel Nganga, if you're in a position to speak, what have you learned so far? Or what didn't you know that has come out very clear? Any attempt, Samuel? Are you in a position to speak? Okay, maybe Fiona, are you in a position to say anything that maybe you have learned so far that was never clear to you?
Okay, so far so good. I've known the definition of data science and the characterization of data that is traditional and big data. And maybe what I didn't know was the definition of big data, but now I do.
Okay, thank you so much. Maybe one more person, a gentleman. Francis, you can, what have you learned? That's Francis Mzembe. What have you learned so far? Maybe even something that you have been doing on social media and you didn't know that people are making money because of your data. Francis, anything that you have learned?
Uh, First of all, like you talked about the Facebook thing, like the pictures or the content that we post on the Facebook, like uh, we normally use like sending those things without knowing whether it's characterized data or not. So on that one, it has really opened up my mind, like what sort of a data that we are sending on the Facebook, and the definition of data science, because we normally know this basic thing without going into deeper thing, or what data science really is. Thank you.
Okay, thank you so much. Um, yeah, another thing that I had I've forgotten to tell you is that in my classes I do give 15 minutes break. So at 9 p.m. we will have a 15 minutes break, then come back. But maybe let me pick another person. I like my sessions. They are very interactive. Philip, what have you learned so far?
So for me, um, I think what I've learned, the new thing I've learned today is just the big data because I didn't know what big data was, and yeah, that's simply it. The rest I had an idea of it.
Okay, thank you. The last person, maybe Salom. What have you learned?
Okay, something new that I've grabbed today is that data science is very dynamic. What we define as data science today might not be it tomorrow. Like you said, in 25 years ago, it was only about gathering and cleaning data and applying the data to statistical methods. But as of 2018, we have integrated other things like machine learning and business intelligence. Thank you.
Okay, thank you so much. So I would like guys to give you a 15 minutes break in case maybe you came just from work or class and you did not get time to refresh. I think we can have that 15 minutes then exactly at 9:16 or 8:16 for our colleague in Malawi, if I'm not wrong. We should be here to proceed so you can have that break. Don't leave the call, just mute and uh, you you come back at exactly 9:16. We will be starting. So maybe just a quick recap of what we have learned. First of all, we have defined what data science is, and what has come up very clearly is that the definition will keep on changing based on the advancement of technology. Then also we have looked at data. In terms of data, we have looked at two major classification. That's first of all, we have looked at what we call traditional data, and we have said traditional data mostly. Uh, One thing about traditional data is that it is structured in nature. And an example is, for instance, a database of the name of students, maybe taking the business analytics expert and certified data scientist course for match intake and so on. We have went further and defined big data, and what has come up very clearly with regards to big data is that from the name is that this data is voluminous. Um, it is it is transmitted at a very high velocity. Also, it is of different nature, like the images that people post, the audio, and so on. And what has led to the emergence of big data is the technological advancements that we have had recently. So having looked at that, the next question that we need to ask ourselves is that what do you do to data? So um, we have two scenarios here, and maybe you can give yourself a minute to name the difference between the two scenarios. I'll give you this opportunity, and I want you to be keen. We have the content here. Imagine the following scenario. You are an analyst for a large company, and your manager approaches you with the following request. We have two requests there. You are an analyst, then you have your manager who approaches you with the following requests. The first one is saying that we need to consider client satisfaction in the next quarter so we can predict churn rate. A churn rate is the rate at which maybe customers stop using a particular product. So we need to predict the churn rate, then oversee the process and come up with some numbers. The next question or the next scenario is that you are that your manager tells you that we have an enormous amount of customer data from the previous quarter. Can you oversee the analysis and deliver an approximation of churn rate for the next quarter? I want you, let me just repeat the two scenarios. You have your manager, and he has given you two scenarios. One is saying that we need to consider client satisfaction in the next quarter. So we can predict churn rate, then oversee the process and come up with some numbers. The next one is that we have an enormous amount of customer data from the previous quarter. Can you oversee the analysis and deliver an approximation of churn rates for the next quarter? What you are required to do is that give yourself a minute to name the difference between the two scenarios. Anyone who have understood the two scenarios to raise his or her hand and try to explain us what you have understood. Yes, Almas.
Yeah, so I think in the first scenario, we are supposed to come up with data. There's no data. As compared to the second scenario, there's already available data to analyze it. I think that's what I understand from the two scenarios.
Okay, thank you so much, Almasi. Another person,
Sorry.
another person, maybe a lady now. Uh, okay, Benson, you can just come up before we go to.
Yeah, I think on the first scenario is we are developing a prediction, while the
Yes.
other one we are just doing data analysis of what has happened. But in the first one, this now because we don't have this data, we are doing predictions. We are coming up with a prediction model, while the second one we are using the data that is already readily available.
Okay, thank you so much, Benson. We can now have Claire. Claire, I saw your hand was up. Yes.
Yeah. From the first scenario, I think you are dealing with traditional data, and then the second scenario, we are dealing with the big data now.
Okay, thank you for trial. So thank you all for the trials. Um, Yes, Venetia, I think you also have something.
Okay, so according to me, I think the first scenario you'll be dealing with real-time data because it's the data that you doesn't have. You have to monitor it for the next 4 months. While the second scenario is for the historical data because you are using a data that is already there.
Okay, thank you so much. I think all of you have understood very well the two scenarios. So, so basically, when we look at the two scenarios, as you have said, is that in the first one, you don't have data. This one, sorry, I have moved to the next slide. But the first scenario is that you don't have this data. So you need maybe to design a questionnaire, a client satisfaction questionnaire, first of all, to collect this data. Then after that, you are going now to predict a churn rate based on that. Then in the first one, you already have this historical data from the previous quarter. Then you are required to analyze it, and therefore after that to deliver an approximation of churn rate and so on for the next quarter. So also something maybe that you guys did not get it clear is that in both you are required to look at what will happen in the future. Like first of all, you analyze, then you predict what will happen in the future. I think that has come up very clearly. In the first one, you are being told you can predict the churn rate. Then this one is talking about an approximation of churn rate for the next quarter. I think also, no, I was interpreting wrongly. This one, the first one, you are required to predict what will happen, but this one now, what it means, the second one, like if maybe you have gotten a churn rate to be at 20%, in the next quarter, maybe you are going to approximate the same. Therefore, the second one is what we call business analytics. Use historical data, analyze, and try to find out what will happen. So, uh, basically, this is now the response. Of course, you need to consider client satisfaction in the next quarter so you can predict the churn rate and oversee the process and so on. But in the second one, you have a large amount of customer data from the previous quarter. So you are just required to do the analysis and, of course, deliver the approximation for the next quarter. But all this is building up to something. The next step, whereby we are talking about pre-processing, data pre-processing, and so on. So, as a data scientist, before even I come here, sorry, maybe you might have already read whatever is there, but I like thinkers, like critical thinking. Maybe as a business analyst, experts, a data scientist, a data analyst, and so on. What has come up? Maybe I just want to post this question to give you this question. Based on this, we have seen in the first scenario, you have data. The second one, you don't have data. So, as a data scientist, a data analyst, a business analytics expert, what comes into your mind based on, like this profession, the nature of your work, what comes into your mind with regards to the data in the organization? I don't know if I have framed my question well. What comes into your mind when you work or when you are working in that organization or when you work you want to start these careers, what comes into your mind with regards to data availability? Let me try to make it very simple. It's just a very simple answer. Yes, Venetia?
Okay, if it would have been me working on the data, first I would have to define the problem, which is the churn rate. Then I would have to understand my data. For the first one, it's like a data it doesn't have. So I have to find and also write a questionnaire on how I'm going to collect it. And for the second one, I'll also have to design and find the data that I have. What are the key points that I'm going to look at? And also, I need to understand the customers and the products that we have.
Okay, thank you so much, Venetia. It is a good trial, but let me now try to bring it on point. Is that as a data scientist, a business analytics expert, or a data analyst, what is clear is that in an organization, when you have been given a role to play in that domain, it is either you will get an organization with data or they don't have data. The end goal, like the manager wants you to deliver. You have the keep of KPIs and so on, and they don't care maybe where are you going to get the data from. And therefore, what is clear is that you need to get these skills to know that how are you going to solve this problem. The problem at hand is the churn rate, right? So, do I have the data? That was the next question. Yes or no? And if no, where am I going to get it from? I think that is what has come up very clear in this situation. Yes, Ferran?
Yes, for example, in the case of if you don't have a data, the way of thinking is, for example, usually in Africa, most of the companies they don't have a structured data or the data is somewhere there. So, for example, as a data, what do you call scientist or analyst, what I will do is maybe create a system, for example, where they can, or a form where they can put the data. Then I will try to maybe provide what they call an analysis from there. But the first, I have to build maybe some application to for the company to have starting from the day I work to have data so that later it might not have a problem for me. That's a way of me thinking, for example, when there's no data. But when there's a data, maybe it's scattered, or if the data is not uniform, maybe I will try to maybe clean, look for something and analyze something like that.
Yeah, thank you so much, Ferran. I think in a company you have to assess. You have to assess like how are these people? Do they have this data? If not, you have to develop a database to store this data. If they have this data but it is scattered, you need to put it in an organized manner. And it is true, Ferran, is that most organizations, I think this issue of emergence of data and so on has got them off guard, and everybody currently is trying to rush uh, and try to sort out. And also, what I came to realize, most organizations also because they don't have a lot of data literacy, the organizations that are building these data science products and so on are trying to manipulate them. And this is I sat somewhere and there were three companies that were pitching, and I found out that one company was trying to manipulate, like they were trying to bring a product that was not I can say it was not a superior product, but because in that organization most of the guys did not understand data science, they were ready to spend millions Therefore, there's need for data literacy. That was just a by the way. But let us proceed now and look at the pre-processing section. So, so what has come up clearly is that regardless of whether a data scientist is given just the collected data, or they have to go through the I can call it the data gathering process themselves. All this data is going to be in raw format. So we have seen in both situations that we had a scenario, the organization had ready data. Another scenario, the organization was supposed to collect the data. All this data, we can say it is in raw format. So, when we are talking about raw data, we are talking about data that is untouched, that needs to be converted into a form that is more understandable and useful for further processing. And therefore, this process of converting the raw data into a form that is more understandable and useful for further processing is what we call data pre-processing. And I think Ferran again gave an example, like you can go to an organization and find out that yes, they have data, but this data is not organized. So that process to try and put together all this data in a form that you can understand is called data pre-processing. Sorry. So when now we are talking about this data pre-processing, uh, we have various ways you can do so. One, we have what called class labeling of the observations. When we are talking about class labeling of the observations, this consists of arranging your data by category, or you label your data points to the correct data type. For instance, um, if you are talking about the traditional data, you can put it as either numerical or categorical. Categorical data, for instance, when you are talking about gender, in this class we are having both male and female. I can categorize in terms of gender. If, for instance, there are images, is it a digital image or a digital audio, and so on. So that is what is called class labeling. You classify the data. Then another way of pre-processing data. First of all, sorry, let me explain further so that you understand. Because we said pre-processing, I want you to understand properly. So we have seen that in both two scenarios, we had ready data and data to be collected, right? So, but all that data is raw and needs to be converted into a form that is more understandable and useful for further processing. So now, one way of doing pre-processing is what's called class labeling of the observation. So when I'm able to classify my data, like this is a digital image, this is an audio, and so on, it means that at least I can be able to understand it. But it doesn't mean that I have analyzed it. I haven't done any analysis, but I can understand that this is a digital image, this data entry is a digital audio, and so on. Another thing on this data pre-processing is what we call data cleansing or data scrubbing. So this one mostly in your data you might have inconsistent data, maybe such as misspelled categories and missing values. So that process of maybe replacing those missing values and trying to rectify the misspelled categories is what we call data cleansing or data scrubbing. Another way you can handle this data to make it understandable is what we call data data balancing. And this mostly happens, for instance, if you have data and the categories in your data contain an equal number of observations, then it means it might not be representative in terms of the population and so on. Like, what do I mean? Let us say I have your data, name of the students, admission number, mobile phone number, and so on. So when I come to the name of the students, I have 20 entries. Uh, when I am coming to admission number, I have 10, and so on. So they are not equal, and so on. So that's called data balancing. Then the last one in terms of data processing, I know this one you will learn more on calls, especially on machine learning and so on. We have what called data shuffling. Um, this one mostly, if you want to arrange your data to eliminate what you call unwanted patterns, and of course to predict the performance of maybe your model and so on. That one we call them, we do what you call data shuffling. Like you are trying to see, maybe you have the outliers. Outliers are like unusual values. Maybe if in this class, if the average, if most people are aged 30 years, then we have someone who is aged 50 years or 60, we say that person is an outlier and so on. And by proceeding with the analysis, they might affect our final result and so on. How are we going to reshuffle? Then we have now what you call data masking. Data masking, mostly we are talking about now protecting uh, personal identifiable information. This one mostly aims to ensure that any confidential information in the data remains private without hindering the analysis and extraction of insight. For instance, today, if I want to analyze maybe in January, sorry, this is March intake, how many students were female, how many were male in my class, maybe how many are still university students, how many are working, and so on. Uh, if I remove the names columns in that data, like your names, it will not affect my analysis because it is true. If I am having a data set and I have your name, year of birth, and so on. So if I have your names, it's when I know maybe Venetia was born in this year. Maybe she's a female, and so on. But if I remove that section of names and I remain only with what do we call maybe the year of birth and so on, it it will it will be very difficult to know uh, whose specific data is that for. That is called now masking. Like you are trying to conceal the original data with either random or false data and allowing the scientists to conduct the analysis without compromising on private details. And I think the last unit we are going to hear, we will be looking at what we call data governance. This is a very serious issue nowadays. If you have been going through the news, especially in Kenya recently, I've been seeing universities being sued for using students' images in advertisements without consent. Um, like for instance, even ourselves, like especially when our students complete the exams and pass the exam. So if they want to be recognized in the company social media platforms, we do have a written consent from them before we publish such kind of posts and so on. So with the current regulations on data privacy and so on, you cannot just share anything without consent from the data subject. The data subject is the owner of that data. Like if you gave us your data for the purpose of admission, you become our data subject and so on. So we have seen data processing. So what has come up very clear in this session is that uh, we were looking at what do you do to data. You have your data. What are you going to do to data? Then we gave a scenario. In this scenario, what came up clearly is that in one situation you have ready data. In another situation, you don't have it, right? Then after that, um, what we saw that yes, you have the data. In the first scenario, you are supposed to collect the data from the field. And the second scenario, you had ready data like that is stored in your organization. The question was, is this data ready? What came up very clear is that this data is not always ready. It needs to be converted in a form that is more useful for further processing. And therefore, that process is called data pre-processing. And we have seen some of the common processing methodologies. One is class labeling of the observations. We have seen data cleansing or what called data scraping. We have seen data balancing. You have seen data shuffling. You have seen data masking and so on. So that's what we have covered. I don't want uh, to give so much content. So from tomorrow we will start from where does the data come from. I have the recording of the session. I'm going to upload to the YouTube and share the private link with you guys. But the presentation, the whole presentation, I'll share, and more other materials that I have. I have a lot of materials at the end of the this unit, but the recording you will be getting daily for you to follow. Having said that, I want to give you an opportunity to ask any questions uh, with regards to what we have covered so far. Any questions? Any question, any comment? It is not a must that it is always questions. Maybe you have comment, recommendation. Okay, even if you don't have a question now, in case it pops up even tomorrow, you can just inbox me. I have my number there in the group. I'll be able to respond. But what you are going to get, I'm going to share the link in the WhatsApp group. I hope you are all there. And okay, someone is asking, he has not understood the difference between a data scientist and a data analyst. I don't know if I have that slide somewhere here. Let me just confirm. Okay, I don't know if I have it, but uh, a data analyst, the difference between data science as a data analyst is that the work of a data analyst just ends on you have your data, you let me use an example here. Let me use, I like using uh, um, a very simple example. Let me pick in this class. Uh, in this class, your data has been collected, like the name of the students, the unit, um, maybe the number of the students, and so on. So, what does a data analyst do? A data analyst role will end up at maybe summarizing this data, like to know how many males were there, maybe 10, how many females were there, 20, what was the mean age of these. Another thing that a data analyst does, maybe a data analyst also might go extra and say, based on this intake, maybe you got this number of students. It can predict also the next intake, what maybe we anticipate to do. But now, a data scientist now, uh, a data scientist will, when you are having your data, for instance, you have talked about data pre-processing. First of all, um, what a data scientist does, you see this data, a data analyst, you have analyzed that we had this number of females, we have had this number of males, and so on. So what a data scientist will do now, a data scientist will want to assist organization. If in this intake we had maybe less females as compared to males, what can we do to ensure that we are having more males as compared to females? So a data scientist will build what you call a recommender system using machine learning that is able to recommend this course maybe to more males than females. Therefore, the business is able to budget or to know when doing the advertisements, know that if you go through this strategy, you are likely to get this more number of males as compared to females. Another thing that a data scientist does in the process of coming up with these strategies, maybe to build these recommender systems, you see, like for instance, in the among the variables that we are having in your data set, we have your name, your gender, maybe profession, and so on. We have various variables. So a data scientist will apply some, will apply not some, but will apply a data analysis knowledge, first of all, to know how are these age of these students distributed. Is it normally distributed, or we have outliers? And if they have outliers, it means that it will not predict the best, it will not give us the best output in the future. So I'm going to apply my data analysis knowledge, first of all, to select, we call them futures, or the most important variables for us to build this model that will recommend this course for more female students as compared to male. So in brief, you see the data analyst knowledge is very limited as compared to the data scientist. I can see that, but a data scientist still has to understand the entire data analyst knowledge for him or her to be able to perform the data science roles. And also another thing is that a data analyst cannot do machine learning, uh, machine learning, mostly cannot do machine learning tasks, artificial intelligence, deep learning, and so on. But a data analyst can as well do some tasks like querying data from relational database such as SQL, can visualize data, and so on. So that's just the brief difference between the two, using an example. But I think somewhere we will get it somewhere. I think it is somewhere as we proceed further because we have just started. Any other question, or is that explanation clear? I think we have a unit on roles in data science. We have that slide. We will come. Let me check that slide if we have it. I think I have it somewhere, and we will come across it. Yeah. So we have a slide on career pathways in data science. You can work as a data analyst, mostly data manipulation and reporting. You can work as a business analyst. Those who are doing business analytics, we are saying that business analytics, you are just looking at historical data and predict the future. You can work as a data engineer. Mostly you process data pipelines from those relational databases and so on. You can work as a machine learning engineer. You can work as a data architect or a full stack data scientist. A full stack data scientist means that, like myself, where I am, we are not so many in that organization. So you find out that I do both data analysis, I do data engineering tasks, I do business analytics and machine learning tasks and so on. So in summary, data analysis is a subset of data science. I don't know if that is clear who asked this question, but we will learn it. I have that slide. Yeah, it is Brenda. Any other question? We have 3 minutes. Yes, it is Gertrude. Yes, Gertrude.
Okay, so my question is, data scientists can do the work of a business analyst. So that means
Hello, I tried to move closer
oh,
to your
sorry.
mic.
Sorry, I had not positioned my mic well.
Okay.
Can you hear me now?
Yes, yes.
So I was saying, since data analysts can do the work of a business analyst, so employers would prefer data analysts to business analysts. That's my question.
Okay, thank you so much. To respond to that question, I can say that it depends. Um, First of all, it depends with the maturity of that company with regards to understanding of these domains. The reality that I have come, the reality that is existing currently, most organizations do not also understand very well to differentiate between those disciplines. But I can say, yes, a data analyst still can do a business analytics work and so on, because business analytics involves using historical data to explain what happened in the business. Mostly it ends there. But as I said, that a data analyst can further look even at maybe what might happen in the future, can predict the future. Like he has an extra skill and so on as compared to the two. But both, it's just they can just do the same thing. So the bottom line is that it depends with the organization how they want to classify it.
Okay, thank you.
Okay, thank you. So for Brenda, perfection of skills involves doing a lot of projects. As I mentioned earlier when we started, is that we, apart from the projects that we are doing and so on, we have community learning on Fridays. You can be part of those community learning. Of course, it is too early for you guys. Maybe you will just be spectators during the first few months, then you also pick up. But continuing being part of the practicing, taking various challenges and so on will make your life easier. Even for myself, yes, I'm a senior data scientist, but does not mean that I don't go to YouTube because things every day is a learning. Yes, I know how to use Python, I know how to use R, I know to build models and so on, but it does not mean that I'm perfect. I have to. Some things you might find that it is not going the way you wanted, and I keep on doing my own research to ensure that I keep on learning and improving on a day to day basis. So the bottom line is taking projects, challenges, and so on. Then you will be in a position to continue perfecting your skills. The community sessions are online. Do happen on Friday. The physical session that we might have for those who will be available, but because the attendance has never been 100% during there's a last unit on the project, internal project that will be required to do a project and present for evaluation for for evaluation purposes. Let me first of all stop recording because this